Okay, now welcome back, viewers. Now talking about addition of fractions with uncommon basis, that is when adding fractions when their denominators are not the same. What are those things we need to do? Instead of looking for the LCM, look at your numbers, look at your denominators. If they can divide, if there is nothing that can divide it, or if it can divide completely, there are different methods we use to achieve the LCM. If you look at the questions I have here, the denominators, they can be divided. Like nothing can divide the two denominators. Mostly they are prime numbers. They can't even divide. Nothing can go there. Nothing can divide these numbers. If you look at 2 and 7, it's not possible for me to divide 2 and 7 without having a remainder. It's not possible for me to divide 3 and 5 without having a remainder. It's not possible for me to divide 4 and 5 without having a remainder. And it's not possible for me to have 2 and 3 without having a remainder. Once I check the denominators and I notice that nothing at all can divide the denominators, I multiply them. I multiply the denominator. For example, now 2 and 7 cannot divide. To get the LCM, just multiply. Only when you see that nothing at all can go in the 2, like no numbers can divide the 2 at the same time, that is when you use this method. You multiply them. I hope you are taking notes. Now, if I multiply this now, 2 times 7 gives me 14, meaning the LCM is 14. If we use our normal LCM method, this is 2, this is 7. 2 can go, 2 in 2 is 1, 2 in 7 is impossible. I drop my 7. I'll use 7 because nothing goes in 7. 7 is a prime number. 7 in 1, I drop 1. 7 in 7 is 1. I'm left with 2 and 7. 2 times 7 is 14. Instead of going through this means, instead of going through this, as a year 5 or year 6 learners, you are working with time. And they say time and tide wait for no man. So just look at your fractions, look at the denominators you are giving. Are they the same? If they are the same, of course, remember in our previous video, if the fractions are the same, just bring out one of the numbers as your LCM. Here now, if they are not the same and nothing at all can divide them, nothing can divide them at all, you multiply them immediately. You multiply instead of going through this step of looking for the LCM to save your time. Now we have 14 as the LCM now. 2 in 14 is 7, but remember before that, drop your 1 times 2 in 14 is 7. 1 times 7 plus, how many 7 can I say in 14 is 2? But bring your 3 here. 7 in 14 is 2. Right? 1 times 7 is 7 plus 3 times 2 is what? 3 times 2 is 6 over 14. 7 plus 6 gives me 13 over 14. This is a proper fraction, so I don't need to take it to the lowest term. Nothing can divide. Nothing can divide both the numerator and denominator. Now, the next question now. Remember, again, if you are sure that there is nothing that can divide both denominators at the same time, nothing can divide at all, just multiply the denominators to get your LCM. Now, the next question says 5 over 3 plus 4 over 5. How do I solve this question? First, rule your 9. LCM of 3 and 5. Of course, 3 and 5 cannot be divided. Just multiply. 3 times 5 is 15. Next step, write your 5 down. 3 in 15 is 5. You put your 5 here. Plus, drop your 4. 5 in 15 is 3 times 3. 5 times 5 is 25 plus 4 times 3 is 12 over 15. 25 plus 12 will give me 37. I have 37 over 15. Now, this is an improper fraction. I need to take it to mixed fraction. Remember what I taught you when we are working with fractions with common denominators. Now we have 37 over 15 now. I'll have to change this to a mixed fraction. I'll change this to a mixed fraction. How many 15 can I see in 37? Of course, you know, 15 times 2 is 30. 2, 30. 37 minus 30, we have 7 over 15. Now the next question says 1 over 4 plus 2 over 5. How do I solve this? Since the denominators are not the same and there is nothing at all that can divide, now I'll multiply the denominator. 4 times 5 is 20. 20 divided by 4 is 5. 1 times 5 plus, I'll drop my 2. How many 5 can we say in 20? That is 4. Yes. 1 times 5 is 5 plus 2 times 4 is what? 8 over 20. 5 plus 8 is 13 over 20. And there is nothing that can divide. I hope you understand. Now, to recap what I've just taught or what I've just explained, I said we have different ways of solving for our LCM. Instead of using the prime factorization method, use the easiest way, because during examinations we will be working with time, so we need to find the easiest way to get our answers. Now, if you notice that the work given to you, the denominators are not the same. 1, okay, you finally confirm that the denominators are not the same. Don't just multiply like that. Check again. If there is something that can divide, if there's something that can divide it, don't use this method. But if you check and you notice that nothing at all can divide the numbers completely, nothing can divide the numbers completely, then you can multiply the denominator. For example, now we have 2 and 7. If you check 2 and 7 now, nothing at all can divide them completely. So we have to what? We have to multiply the denominator. Same thing goes for 3 and 5. Same thing goes for 4 and 5. Nothing can divide them completely. There is also another method I'll be sharing in my next video. Okay, we've checked our denominators. We notice that they are different, but something can still divide. For example, we have 8 and 6 as our denominator. Of course, 8 and 6 cannot divide completely, but a particular number can divide 8 and 6. Do we use this method? No, this method will not work. You will get the wrong answer because something can still divide. So, in that case, I would advise you to look for the LCM. I will advise you to look for the LCM. Thank you.